So here's the cool about including the lump sum with the annuity. It's really easy to turn that into a debt payoff calculator. And what I'm going to show you is that we can just flip the sign of one of the quantities. It's kind of up to our choice, but I'm going to flip the sign of the deposit. Use exactly the same formula and exactly the same spreadsheet. I'll show you on the spreadsheet first to get the idea of paying off a debt. So let's look at this. So here's the deal. I owe the bank $100,000. So that's a debt that I have. It's a bad number. So here, big numbers, big positive numbers are bad for me. And I'm going to pay it off $12,000 a year. I'm going to give the bank $12,000 a year in monthly installments of $1,000. At the same time, the bank charges me 6% annual interest on whatever I still owe them. So every month, they, just like in a savings account, they multiply what's in my account by the multiplier, which they take a half of, or a twelfth of 6%, which is a half percent, turn it into the multiplier 1.005, and they multiply my debt by that much, and that's going to make my debt bigger, which is not so nice as making a savings account bigger. But then I'm going to try to pay off that by paying off $1,000 a year. Okay, and we'll see if that's going to work. Okay, so I just need to look at the spreadsheet and see what do I need to change here. So I start out owing, so the starting amount and the ending amount should be at the start and the end of a year. How much do I owe the bank? I start out owing $100,000. Okay, now the earned here, I'm not going to change it, but that's not a very good word. It's really the interest charged. They're going to add $500 to me, to what I owe. So it's actually going to be $100,500. Now, here's the thing. I'm trying to pay off the debt. So I don't want to add $1,000 to the debt, but I can change that very easily by just changing this to a negative number. And now let's see what happens. I owe $100,000. They charge me $500 of interest, so I owe $100,500. But then I knock that down by $1,000, and so I am a little bit better off that I only owe $99,500. I'd like to only owe $99,000, but they charge me that interest, and that's how the bank makes money. Okay, so then $99,500. They charge me a tiny bit less interest, and then I knock it off by $1,000. This is the second month's um, accounting, and I owe a little bit less than $99,000. I would love to only owe $98,000 since, hey, I put in $2,000 on a $100,000 debt, but they charged me almost $1,000 worth of interest at the same time. So I'm only getting about half of the reduction that I would like to have. So in other words, I'm basically half of this money right now is going just to paying the interest. And it's only the about $500 left over that's actually reducing my principal. But the great thing is, there we go. All I did was I have this exactly the same recursive formula, the same situation of a starting amount, certain interest charged. In other words, we multiply whatever this number is by the multiplier. Then we progressively add, or here it's subtract, an amount. This is exactly the same recursive formula. I just happen to have put in a negative number into the initial data. And I claim that that means we can use exactly the formula that we had before. No modification whatsoever, as long as I just treat this payment as a negative number, so that the effect of the principal and the effect of the payment are counteracting each other. Now, eventually, this should go to zero, I hope. It started out well. Okay, because I'm paying more in my deposit than they are charging me in interest, which is pretty important, and we'll see that later. Then the numbers go down, down, down. Oh, I went too far. The numbers go down, and not too long. This is actually pretty good. In not too long, I get to where actually they owe me money, and then at this point, the debt just is erased, and I'm done. So it looks like about 11.5 years I would pay this off. So that's a pretty good rate of payoff, actually, for something like this. $100,000 debt might be a mortgage on a house, for example. Okay, so this is the cool thing, is that we don't have to change anything about our formula. Let me just do one little graph here to show, to get an idea. We know that annuities kind of look sort of exponential, but they're not really quite exponential. What does this look like? If I just go down to where it's zero, let me just insert um, a line chart. Now this is going to be on a linear scale, okay? And we can see that it starts off paying off at a pretty decent rate because I'm knocking it down $500 a month. That's pretty good. And that's not always true for mortgages and things like that. Sometimes at the start, you're really mainly just paying off the interest and it's incredibly slow. And maybe I'll modify this in a minute. And then it gets fast, it gets a bit faster as I go down because down here toward the end, let's look at what happens toward the end. Hello. Um, Toward the end, they're not charging me much interest anymore. If I only owe like $10,000, they're charging me a measly $50 a month, and I'm still putting in that $1,000 a month. And basically, mostly I'm paying off the principal, and that's good. And that's a typical transition in especially a mortgage payment to from paying off a lot of it seeming wasted that you're just paying off interest to a lot of it paying off the principal. Suppose I didn't pay off quite so much as money. Suppose I was only paying off like $8,000 a year. 667 about dollars per month. Then what's going to happen? Okay, here, um, almost all or lots of my payment, my monthly payment is going to interest, and I'm not making much of a debt. Oh, I just forgot to make it negative. That would be I that would be not good. Okay, there we go. So most of that 666 is going to the interest. When you cancel that out, it does reduce the debt by a little bit. Okay, but now it takes a lot longer. It's going forward. Okay, so now it takes, instead of like what was 11.5, it takes about twice as long to cancel out that debt completely. And if we go back to the graph, we're going to see that same. So here it's much less sloped. It's very, very gradual that you're going down. And then eventually, ooh, it's not really plotting the whole thing. Oh yeah, um, let me just delete that. I need to replot it because it's a bigger range of values. We'll do this, and then we'll do one more quick example where we do it algebraically. So I want you to be able to do it with the algebraic formula and not have to depend on the spreadsheet. Okay, but this is worthwhile. We're going to insert a chart. A line chart. Okay, now you can see more of the curvature. It starts out gradually decaying. The principal is going down because mainly I'm paying off interest, but I'm making some headway. And then down here, it's much, much faster. And I'm much happier about where my money is going. Okay, let's see. Let's do another one. The credit card debt. Okay, so here's the credit card debt. Let me import the formula here. Remember, the cool thing is we're going to use exactly the formula we did for annuity plus lump sum. Okay. And we're just going to plug in, okay, so my $18,000 debt, this is not too unrealistic, at 12% annual interest. So there's three places to put that in. Okay. And 10 years, times. So that's happening for 10 years. And $125 per month. I put that in there just to make sure people are paying attention. $125 per month. Wait a minute. My usual thing here is that I'm supposed to do everything annually. So $125 per month, if you multiply that by 12, that's $1,500 per year. So watch out for month versus year. Okay. So here we go. So it's as if I just sort of left that $18,000 alone as a debt to grow and grow and grow. That's bad. Positive numbers are bad, remember here. But then this is sort of like an annuity, and the crucial thing here is make that negative. This is kind of like an annuity canceling that out. Okay, so that's kind of a fun thing that works to calculate a debt. Oh, and I need the 10 here. So really quite straightforward. If we can convince ourselves that it's this magic thing of just making the deposit negative, works, and uh-oh, that's not good. I owe more money than I started with, okay? So let's think about why that's true. $18,000 at 12% annual interest, okay? That is 1% per month, and 1% of that is $180. So they're charging me $180 in interest, and I'm only paying $125 off per month. So in fact, my debt is growing continually throughout the whole time here. Okay, and I think I plotted that on the calculator. I put in these numbers with the minus, with the 0.12 and everything. I just put in the right numbers, and here's my debt. That's a great kind of picture to see for my savings. That's a horrible picture to see for my debt. The debt is going from $18,000 up to, within 20 years, it would exceed $50,000 by quite a bit. That is not a good situation. Anyway, that's a good example of how this stuff works.